Welcome back to True North Mechatronics. In this episode, we're kicking off a massive architectural upgrade to the Sparkbot platform. We're engineering the mobility base to integrate the same power module used in our flagship TitanBot. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. I'm going to create a horizontal line using the polyline tool that is symmetric around the y-axis. We're going to do that by clicking on the extremities of this line segment and using the Constraint Symmetric tool. Alright, so let's set the length of this line segment to 72 millimeters. And we're going to set the distance to the x-axis at 47 millimeters. Now let's grab the polyline tool again, and on the right-hand side, let's come up vertically and over horizontally. Right-click to clear our tool. This line needs to be constrained horizontally, so make sure that you've got your horizontal and vertical constraint markers in place. Let's come on over to the left-hand side and create a similar shape. And we're going to come down at an angle, and then we're going to come down to the x-axis, and then we'll go right following the x-axis, and right-click twice, once to stop the line segment, once to clear the tool. All right, let's add some more constraints here. We're going to make these two vertical line segments equal to each other, and we're going to set the length of that vertical segment to 23 millimeters. Let's set the vertical length of the left-hand side to 60 millimeters. And we're going to set the distance between these two top left points here at 80 millimeters. All right, zoom out so we can see our constraints. And let's set this top right-hand constraint at 15 millimeters for this part. Okay, we need to close our shape. We're going to do that with an arc. So let's go grab the Create Arc by Center tool. We're going to begin by left-clicking on the x-axis. And then we will put the crosshairs of our tool over top of that top left-hand vertex. And we will bring the crosshairs down and put the crosshairs over top of the vertex on the end of our line segment there. So left-click on that, and the line will increase in length to match. Make sure that you end up with a red vertex dot there, and this one, of course, should be green. Let's set the radius on our arc. So using the dimension tool, we'll set that to 302 millimeters. And our shape is fully constrained, but we need to add a fillet at the corner here. So here's our fillet tool. Grab that and left click on that top left corner. Using the dimension tool, we'll set the radius of this fillet to 20 millimeters. And with that, we have fully completed all the boundary shapes that we need for our mobility base. So we're going to close out of the Sketcher workbench, and we're going to pad this shape out to 3 millimeters. Now we're going to iteratively add a number of holes and pockets to this shape. So we're going to repeat this process more than once. So left click on the top face of our base and click on Create Sketch. The first set of holes that we're going to pocket are going to be right here. So let's grab the circle tool and let's create 2 circles. Now we want to make them horizontally collinear, so we do that by using that tool there. We're going to set the diameters so that both holes have an equal diameter, and we'll set the diameter to 3 millimeter. We're going to set the center-to-center distance between these two holes at 8 millimeters. This comes from the spacing between the holes in the metal bracket that connects the TT gearboxes to our base. So at this point in time, these holes move as a set. We're going to set the distance of these holes to the x-axis at 25.5 millimeters. And we're going to set the offset distance to the y-axis at 16.5 millimeters. All right, so this set of holes now is fully constrained, and we're going to turn our attention now to the back of the mobility base. And we're going to add 2 holes at the back. These are going to be used for attaching a retainer that will hold a caster. So we will set the center-to-center distance between these 2 holes at 19.5 millimeters. We also need to make sure that these holes are horizontally collinear. So we use that tool to do that. Let's set the diameter of both of these so that they're equal, and let's set the diameter of these holes to 3 millimeters. These holes now move as a set, so let's set the offset to the x-axis at 6.75 millimeters. Let's just bring that up so we can see that. There we go. And let's set the offset distance to the y-axis at 81 millimeters. All right, so this now fully constrains these 2 sets of holes, and that's enough for this sketch. So we're going to close out of the Sketcher workbench, and we're going to pocket those holes. And 5 millimeters is thicker or deeper than the 3 millimeter thick base that we've created, so we'll accept the default of 5 and press OK. And now we need to move on to the next set of holes or pockets that we want to create in our base. So left click on the top, left click on Create Sketch, and we're going to create 2 rectangular pockets next. The first rectangular pocket is going to be symmetrical around the y-axis, and it's going to create clearance for the 20 slot encoder discs that get connected to the end of the dual shafts on our TT gearboxes. Here we're going to set the vertical width of the symmetric pocket to 5 millimeters, and we'll set the horizontal width of it to 21 millimeters. Let's set its distance from the x-axis to 17 millimeters. And we need to make it symmetric. So left click on the 2 vertices on those line segments, left click on the y-axis, and click on Constrain Symmetric. All right, so this encoder slot is now fully constrained. Let's move on to this pocket over here. This is going to allow an IR sensor, an infrared sensor, to pass through the bottom of the base. This will allow us to detect the difference between black and white lines. And so this is going to be our line following sensors. So we've set the width and height of these pockets. Now we need to set their distance away from the x-axis. 12.25 for the x-axis distance. Let's just zoom in so we can see those constraint numbers a little bit better. And let's set our distance away from the y-axis, and we'll set that to 39 millimeters. All right, so our 2 rectangular features are fully constrained, so we can close out of the Sketcher workbench, and we'll pocket those shapes, accepting the default of 5. All right, and so now we're going to create another set of pockets. Now these are going to be individual holes. The first hole that we're going to create is up here in the top right corner. You can think of this feature on our base as kind of like the bumper of the robot. It just sits in front of the wheels. So that's going to be a 3 millimeter mounting hole. We're going to attach a scoop to it when we convert this into a sumo bot later. So this is our scoop mounting hole, and we're going to set it so that it is offset from the x-axis by 65 millimeters. All right, so there's our first mounting hole, fully constrained. The next hole that we're going to create is down here at the front of the robot, and this hole is going to be used to secure our ultrasonic sensor. This will allow us to detect obstacles in front of our robot. So we'll set that 18 millimeters away from the x-axis, and we'll give it an offset from the y-axis of 50.5 millimeters. All right, so there's our second hole fully constrained. And now we got one hole here in the middle of the robot base, and this is going to secure a pedestal that will support a vertical frame rail. And this vertical frame rail will help balance the battery on the top of the robot. All right, so let's give this a offset from the y-axis of 26 millimeters, and we'll give it a distance from the x-axis of 31.5 millimeters. Okay, so just have a look at those three holes that we've created. They're all fully constrained, and we can close out of the Sketcher workbench now and pocket those through the base. Now we're going to add two holes on the back of the mobility base here. These two holes are going to secure a sliding lock. We're going to have a removable cover that sits over top of the Vitronics bay. That's just the area where the robot's electronics are going to sit. And that removable cover will allow access to the electronics bay. So we need a lock that will keep that cover in place so that it doesn't come off accidentally while the robot is in motion. So we'll set the diameter of those to be equal to each other, and we'll set that to the major diameter of our PT screw. The PT screw is a coarse threaded screw that we use for joining together plastic pieces that we 3D printed. So let's give this an offset to the x-axis of 52 millimeters and an offset to the y-axis of 96 millimeters. So those holes for our Vitronics enclosure cover are now fully constrained, and that's all we're going to add to this particular sketch. So we're going to close out of this and pocket those through. But now we have completed making all of the pockets that are symmetric on both sides of our mobility base. So now it's time to mirror what we've created. So in the tree view, left click on body, the entire thing should turn green. And we're going to use the mirror tool. But here in the mirror tool, we're going to come down to the plane where where the reflection happens, and we're going to select reference. And then we're going to zoom in, and we're going to highlight this inside edge there. And when we do that, we get a reflection of our part, a mirroring of our part across the x-axis. So when you see that, click OK. And now we've got three groups of holes that are not symmetric across the x-axis that well, partially symmetric. So we're going to left click on the top of our shape that we've created and create a sketch. These three holes here are technically symmetric, but creating them or using them in the later step here in the video causes problems. So create those three holes. Make sure that they are coincident with the x-axis. You should be able to left click and try to drag them off the x-axis, or you should see this this tangent constraint here. So as long as you see that tangent constraint, then all three of those holes are locked to the x-axis. We're going to do a center-to-center distance of these right-hand holes. We're going to set that to a distance of 40 millimeters. And we're going to set the offset distance from the y-axis for this left-hand hole to 26 millimeters. And all three of these holes are going to have the same diameter, so we're going to set all three of those holes equal to each other, and then we're going to set the diameter to 3 millimeters. Now we have 1 degree of freedom here. DOF stands for degree of freedom. And we're going to lock the center of this right-hand circle away from the origin here. I'll explain why in a second. Let's set that to 39.5 millimeters. Now, if we tried doing it the other way, FreeCAD would have tried to automatically lock the center of this circle to the origin. It would have just assumed that that's what we wanted. But we don't want that. We want to have that 0.5 millimeter difference. So Make sure that you do have 40 millimeter center to center distance and 39.5 millimeter offset from this first hole here. All right, so that's our first 3 holes done. Our second set of holes is up here. And this set of holes is going to be used for securing a panel for our switch. This switch will allow us to turn on and off the power to our robot. So we're going to create a center-to-center distance between these two holes of 10 millimeters. These 2 holes are going to have an equal diameter, but this time we're going to set it to the minor diameter on our PT screws. So we're going to set that to 2.8 millimeters. The minor diameter is the inside part of the screw. And it allows the threads of the screw to bite into the plastic. Okay, so these pockets now are going to move as a set. So let's set their offset with respect to this bottom hole here. We'll set that bottom hole's offset from the x-axis at 28.5 millimeters. And then we will set its offset to the y-axis at 104.5 millimeters. All right, so let's just move these constraints so they're a little bit easier to see here. Maybe we'll do that. Okay, so there's that set of holes fully constrained. And we have one more hole to add. This hole down here is going to be used for securing the Vetronics platform to the mobility base. So it'll keep the electronics from wandering. So we're going to give it an X offset of 20 millimeters and a Y offset of 50 millimeters. Let's just tidy those up for you. And let's also set the diameter to the minor diameter of the PT screw. So there we are. There's the full set of holes. And if you're speed running this, there's the full set of constraints that you need to use. All right, so we're fully constrained here in the solver message. We can close out of this and pocket, whoops, cancel that. Pocket those holes all the way through. I think we need to back up. Click on the sketch, there we go. Click on the pocket. There we go. All right, so we've pocketed all the way through our base, and we can confirm that just by tilting our base and having a look at it. There we go. Now, if we wanted to 3D print this, then at this point in time, we would just export our base. To do that, we would left-click on the body in the tree view, make sure the entire thing is green, and then we would go up to File, choose Export, and then we're going to choose a folder where we're going to be able to find this later. For me, I'm just using the desktop, and we're going to give it a name. So right now, it's saving it as an SVG. I want to save this as an STL. So let's select STL mesh and make sure that I've got the appropriate extension, STL, and now I can save this. And if I wanted to, I could import this into Bamboo Studio or into my Cura slicer and slice it and print it. However, there's another option. We can cut this base with a laser cutter out of MDF. And so I'm going to show you that process next. So in order to create an SVG file that can be sent to a laser cutter, we're going to go over here to the tree view, and we're going to expand each one of our process steps so that we can see the individual sketches that we created earlier. Now I'm going to turn off the visibility on the body by left-clicking on this little eyeball here. And I'm going to now click on the first 5 sketches. So I'm going to click on the first sketch, hold down Control on my keyboard, and I'm going to click through all 5 of those first sketches, so I'm not clicking on that bottom sketch. Now, I need to be in the Sketcher Workbench to make this work, so I'm going to come up here to the Sketcher Workbench, and I'm going to use this Merge Sketches tool. When I do that, it shows me the symmetrical half of the non-mirrored base here, and I want to now mirror this part. So the Sketcher Workbench also has a mirroring function. So left click on this master sketch that we created and then left click on the mirror tool. We're going to mirror it over the x-axis. And at this point now, we have 2 sketches. Now we need to merge these together into their own master sketch. So I'm going to turn them off, so I'm going to hide them so they're not visible. And using Control, I'm going to select both of those sketches, and I'm going to merge them into a master sketch. So now I have a single master sketch, but we have a problem. This sketch has a line of symmetry down the center that follows the x-axis, so we need to remove that. So in the tree view, we're going to double-click on Sketch 007 to open it up in the Sketcher workbench, and this is your first opportunity to really look at what it would have taken to build this mobility base as a single sketch. And so you can see there's a lot of opportunity to make mistakes with this many constraints in one space. So this is why we're using this process. All right, so this line of symmetry that follows the x-axis is right here. There's two of them, one on top of the other. So we have to left-click on it and press the delete key on our keyboard that gets rid of the first one. And there's a second one there, so left-click on it, press the delete key, and when you've done that, you should be able to see the x-axis now running through the center of the mobility base. And when you hover over top of the x-axis, you should see it turn blue right through. All right, so when we click close now, that line of symmetry is now gone, and we're ready to merge in the very last sketch that has the non-symmetrical pockets. So I am going to hide the current master sketch. Holding down Control, I'm going to also select Sketch 005, and I'm going to merge those two sketches together. So now here is my final and complete sketch. Now I need to convert this into an SVG because that's what I need to send over to the laser cutter. So in the tree view, I'm going to left click on that sketch. It's going to turn green. And now I'm going to go File, Export. And here, my file type now is going to be flattened SVG. So there it is there. And again, I got to change that extension, SVG. And I'll save that to the desktop as well. Now, the next thing that I need to do is I need to go into Inkscape, which is my vector graphics program, and I need to make a change to how this file was created. I'm going to open the SVG from the desktop that we created. So there we are. There's our SVG file. So I'm going to open that up. And you can see that this file, first of all of the line segments are in this light gray color. So I'm going to left click on the sketch and I'm going to change its color. And the easiest way to do that is come down here to the color palette, left click on the color black, drag your mouse pointer over here to the bottom left-hand corner where you see stroke and it says the word unset. Let go of your left mouse pointer, and when you do that, your stroke color for your design will now be the color black. Now, the Glowforge laser cutter that we're using, it processes different cut operations based on line segment color. So we want all of the circles and rectangles to be cut first before the outside perimeter of our mobility base. So we're going to use the node tool and we're going to left click on that outside shape, and all we have to do is just give it any other color besides black. And then when we send this newly modified SVG to the Glowforge laser cutter, the software will give us the opportunity to choose what we want to cut first. And we're going to cut the black first and the red second. All right, so with that, we have now completed the Sparkbot base. We've created an STL version that you can send to the 3D printer, and you now have an SVG that you could laser cut. Chart your course, build your world. See you in the next one.